All right. Are we all ready, or are we still expecting someone else? Okay. I don't know. I don't know about the camera here. I'm just gonna stand up and talk. It's better for me. Uh, there's gonna be a demo later where I'll sit down. So for those who want to see my face, you'll have a chance. Then. Okay. I'm gonna talk about open pulsating today, and I'm Anders, and I work for Styra, the company or the founders behind the OPA project or Open Policy Agent. I have a pretty long background in working with identity systems or in software development in general, but specifically in identity systems. So I've been working a lot with standard bodies like OAuth, OpenID Connect, SCIM, and so on. And working for various identity vendors, one of the things that I wanted to, or a common challenge that our customers would ask is okay, once you established an identity of a user or a workload, what do we do with that data? An identity system, what you come in to do there is you issue some form of certificate, maybe a JSON web token or something where you say okay, we know that the user is who they say they are, and here you have your jobs or your certificate. How do we use that data now? And as an identity vendor, we didn't need to care for that. It was not our responsibility. That's the domain of authorization. But of course, our users, they were still they had to solve all of these problems. So after a couple of years, I got interested. What if it was my problem? How would I choose to solve this? And what's the best way to deal with authorization and data and what you actually can do or can't do based on who you are and other data. So that's how I found out about OPA. And this is my third year working in the project. It's a year and a half working for Styra. Before that, I worked for a company where we integrated OPA in a large and diverse organization of about 700 microservices. So when I'm not working with this, I enjoy cooking, food, football, and if you wanna get in touch after, it's just my first name followed by my last name on most of these social media. So the problem, I think that it's a pretty good thing to start with, what is the problem you're trying to solve here? How are you actually making our lives easier? And I think the challenge or the problem with OPA that we're trying to solve is basically this. It's to manage policy in increasingly distributed, complex, and heterogeneous systems. And when we talk about policy, what do we mean? And what is a policy or what is policy? It's basically a set of rules. Just as a real world policy, basically. That's what a policy is. That's basically the definition of a policy. It's a set of rules. So any system where you have rules, there you have policy. And of course, tech or IT systems, what are they? They are full of rules. That's basically every if, else, then statement is a rule, right? It's basically something that is conditional. So if the user has this or that role, they should be allowed to do this or that. Or if the deployment has at least 2 replicas, we should allow it to be deployed. Well, we should not deploy it if it exposes sensitive data on the public internet and so on. So all of these rules are basically a big part of any software system. But these kind of rules, they are all, it all gets more challenging once you have an organization which is growing. And you start to introduce more and more technologies, frameworks, and so on. And the company where I was previously at, we had 13 different tech teams in 13 different countries. Or we had more teams than that, but we had teams in 13 different countries. And in any office that you went to, they all had their own kind of flavor of the day. So everyone wanted to do either if it was Ruby on Rails, or if it was React, or if it was Kotlin or whatnot. So the problem, and that's fine. That's one of the great things about microservices is that you can allow for some freedoms that you wouldn't have working on a big like monolith single piece of code base. So if your teams want to work in a diverse environment, like yeah, maybe you should let them. But the problem is, of course, like with regards to policy, these rules, they are often not just something that developers themselves can just kind of come up with. Those are something that comes either externally, like I don't know, the GDPR, or just organizational policy, where you not just want, but you need to ensure that any user with a given role has or has not a given set of permissions in a software system. And it doesn't matter if that system was written in like Ruby or Rails or Ruby on Rails or Java or Kotlin or C++. So basically that's the challenge we're trying to solve. We want to ensure that when an auditor comes in and asks like, what are the rules in this system, it doesn't matter how heterogeneous or diverse that system is, we kind of have one way of defining policy. And we kind of already covered this, like a modern application stack. So of course, it's going to consist of one or more, or maybe all of the above. And your applications are going to have to be deployed somewhere. And you're going to want policy for that as well. You're going to want to know, like, or you're going to want to decide what kind of applications are we okay to deploy. Do we have requirements on things like availability, security configurations, and so on. And beyond that, of course, you have the infrastructure itself, where you might want to have rules dictate things like, yeah, we might not want to have S3 buckets where everyone can read the data in there. So no public access, no exposure to the internet, and so on. And just basic sane security configurations that we want to enforce. And at the bottom of the very bottom of the application stack, we have like data sources, where we also want to enforce a ton of rules. So one thing to note here, like most of these systems, they already have some way of kind of managing policy, whether it's like hard-coded or if they have like some more advanced or organized way of doing it. But the problem is basically once you start to scale out your organization, or once you start to adopt more and more of these technologies, it just gets more and more difficult to answer this question, like where are the rules of this system? And how do you know which ones were enforced at a particular date and time? So the goal of the OPA project is basically to unify policy across the whole stack. So that's basically what we're trying to solve here. That's the role of OPA. So OPA itself, it's an open source general purpose policy engine. And when I say general purpose, that's really why it works with all of these kind of diverse technologies. It wasn't meant to solve a single problem. But it's a general purpose policy engine. So you ask it questions and you retrieve answers. And we'll look into more in a bit how that works. But it offers a unified toolset and a framework for working with policy across the whole stack. It decouples policy from application logic. And this is kind of one of the key concepts of OPA. So just as you decouple storage and move that out from your application and maybe have a database or some other storage engine take care of that, OPA works exactly like that. So rather than having policy coupled to your code, you rather have your application go out and ask OPA, should this be allowed or not, or whatever question it might be, and OPA will make that decision for the application. So in a perfectly decoupled application, your application has no code dealing with users, no code dealing with permissions. Because that has been decoupled and delegated elsewhere. So if you have some code or code path that is only reachable if you're an admin or so on, then you did it wrong, because that should not be the responsibility of of the application. That's kind of just as your application should not write files to disk or so on, unless that's the purpose of your application, of course. If you're writing a database, you probably want to write files to disk. So anyway, these policies, they're written in a declarative language called Rego. And since it's a general purpose policy engine, there's a whole range of use cases. Kubernetes admission control, where the Kubernetes API server asks OPA, should we deploy this or not? Microservice authorization or just app authorization. That's a very common one as well. Infrastructure policies, like what should we allow in our infra? Data source filtering is another topic where you might send some data into OPA and you get another result back based on what that user is allowed to see. CI/CD pipelines, what should we deploy or not? So basically, OPA doesn't decide anything. And we'll see in a bit here how that model works. But before we get in there, just might want to mention here, it's an open source project. Again, 270 contributors, 75 integrations. A lot of GitHub projects that are using OPA in their own integrations. So it's a pretty vibrant community. I don't need to read all these numbers, but yeah, 130 million downloads. So we're fairly established by now. But of course, OPA is not just an open source like hobbyist project, but it's actually used by some of the largest organizations in the world. And if that was not enough to convince you, like maybe this Kelsey Hightower quote will do. The Open Policy Agent project is super dope. I finally have a framework that helps me translate written security policies into executable code for every layer of the stack. That's basically the idea of OPA. Sorry. All right, so if that's what OPA is, how does it work? How can it work with so many technologies? I think like there are two key concepts here with regards to OPA that makes it work in these diverse technologies. And of course, most of these technologies, they had no notion of OPA. They didn't build their products to have like, oh, let's have OPA do our authorization. There are maybe some modern products that do that, but most of these they had no idea that OPA was even a thing. So how can it work with technologies where they had no idea about OPA? So the key here is the policy decision model and its Rego. And to start off, the policy decision model basically works like this. You have any service, and with service, we have a very broad definition of service. It's basically anything that serves a request to a user or another client. So it could either be the Kubernetes API server, it could be your microservice or application, it could be a Linux PAM module, it could be a Kafka broker, it could basically be anything that serves a request. That's our definition of a service. And when that request comes into the service, and the user asks for something, rather than making a decision on that ourselves, we delegate that responsibility over to OPA. So we send over a policy query. We just say, we have this user here or this client. It's trying to access this path or this topic or this queue or whatever it might be. Should we let them do that? So they're sending over that query, and based on the policy we loaded into OPA, and optionally external data, that data could be like from any number of data sources, we return a policy decision. And the key here is the query is just JSON, and the decision is just JSON. So any system that's capable of parsing and dealing with JSON can work with OPA. As for deployment, OPA itself is just a single lightweight little binary. Since it's lightweight, the preferable model of working with OPA is not to have one big OPA that everyone goes to for decisions. Rather the opposite. Like for every service you deploy, you deploy an OPA next to it. So it's like it's a little tiny little oracle that you can ask for, but it's only meant to be for that service. So in a Kubernetes context, that would normally mean like a sidecar. So you deploy an OPA inside of the same pod, and your application queries for that on the local host interface to minimize latency, of course. But the normal way of communicating with OPA is via the REST API. So OPA itself runs as a little service. You just query that. It's normally about a millisecond of latency since it's on localhost. But if you're writing an application in Go, you might want to use it as a Go library or so. And there's also more integration options like Envoy, Istio plugins. There's WebAssembly. There's an intermediate representation, just very low level format and so on. So there's a lot of ways to integrate OPA. And that's kind of key to why OPA works with this diverse set of technologies. So that was the first thing, or the first kind of key concept why OPA works in so many of these contexts. So the other thing is Rego, and that's the policy language we use in OPA. So it's a declarative language. So it means like rather than saying how you want something done, you just say what you want done. And Rego tries to figure it out for you. A policy, just like we talked about in the past year, it's just a number of rules. That's basically what a real-world policy is, isn't it? So the way we designed OPA is to kind of try and mirror that. So a Rego policy is also just a number of rules. And these rules, when you query them, they can return any value that is valid JSON. So it's commonly true or false. When you ask things like, should the user be allowed or not, that's going to be like a Boolean answer. It's going to be either true or false. But you might also want to know why was the user not allowed. You might want to return a string or maybe a more complex object. So since we're now dealing with policy as code, we get all the benefits of dealing with anything as code, which is, of course, we can work with tests. OPA ships with its own like unit test framework. So we can unit test our policies in isolation from applications. But basically, any of the benefits of working with anything as code, which is, of course, like code review, linting, collaborative tools, and so on. It's a well-documented project, and there's a playground where you can try it out without even having anything installed. All right, any questions so far? None, all right. So at this stage, I'm actually gonna sit down. So I think it's gonna break my neck here if I'm gonna try and do some live coding while standing up here. Okay, so we talked about Rego, and I just want to show you all how that works. So I'm gonna open up my editor here. It's kind of hard to see, is it? I'm going to create a new file. I'm just going to say policy.rego. It's hard to see. Zoom in. Enhance here. Yeah, let's try it out. Okay, so first thing I'm going to do, I'm going to create a package. I'm just going to call it policy. The package is pretty much like a namespace or a package in other languages like Java or Node. Can you see something? Good. So that was the easy part. The next part is we set a policy is basically a set of rules. So how do we define a rule then? So the kind of anatomy of a rule is basically this. You have a name of the rule. In this case, I'm just going to call it allow. And these names, they have no meaning in Rego. Since it's a general purpose policy language, it doesn't it might make sense that allow or deny would be like keywords, but it doesn't mean that in OPA. It's just a name that we give it. So we're going to say allow. And And the anatomy of a rule here is kind of an inverted if statement or if then statement. So rather than saying like if x is equal to true and y is equal to 1 and yeah, foo is equal to bar. So this is how you do it in most programming languages. You'd say something like this, and then you say maybe do something like this: allow is equal to false. But if all these conditions are true, then you want allow to be equal to true. So Rego, we kind of flip this equation around and we invert the if statement. So rather than declaring the conditions first, we say allow is equal to true if all the conditions down here are true. So it's kind of reverted or inverted. Because in Rego, these kind of conditions or assertions, that's where the action is. So it kind of makes sense that that is what you keep in the body, and the actual return value up here, that's the least interesting part. It just says like if all the things down here is true, allow should be true. So if we do something silly like just put a constant here, we might say that if 1 is equal to 1, we know that to be true. Then when we evaluate the allow rule now, it should be true, right? Because the conditions here, I'm going to hand some more here. You can see that. So what I'm going to do now, I'm just going to say OPA eval, which is the most basic primitive way of querying for anything from OPA. It's just like a command line tone. So I'm going to say from the data or from the policy Rego file, query for the data policy allow rule. And what we got back there is just true. So now we asked OPA, are we allowed or not? And of course, OPA is always going to answer allow here because that's a constant condition. And in a real world policy, we might want to add, like remember the application or service actually sends a query to OPA. So we can use the input of that query to do something meaningful. So we might want to ask, and that is a variable called a query in the real world might look something like this. Might have a user, and that user might have a name. Just gonna see honors here, and that user might have some roles. And that's probably going to be a list or so. Developer, and along with a user, we might want or need some details from the actual request. Was it a GET request or was it a POST request? And to what path? What's the path components here? Let's say someone is trying to read from the user's endpoint, or Anders is trying to read from the user's endpoint. Now we can work with that data, just simple like JSON notation. So dot means just step into the input. So if the input user roles, or if the input user name is equal to Anders, we should allow this. That's another silly example, but okay, let's try this out. And now we're going to have to add the input file here in our query, and we can see yes, this is true. So what if we change this now to, I don't know, Eric? Try this out, and we see now like, oh, it was no longer true. It's actually undefined because in OPA, if something does not evaluate, and OPA, the evaluator is going to stop on this line. It's just going to say, this is not true. I'm just going to stop here. Doesn't mean that you might think intuitively that, okay, it should be false then, but OPA doesn't really have that notion of a default. So if we want that, we could always say like by default, allow should be false. And if we query it now, we see that indeed, since the allow rule did not evaluate, it's going to fall back to the default value. So, okay, but this isn't really a useful policy just to check for a username. What we might want to do there, though, is we might want to say like if any developer should be able to read the users or list the users. I'm just going to do a small thing here. I'm going to future keywords. There's a few like niceties in recent version of OPA that I'm going to use here. So I'm just going to say developer in input user roles. So what we're going to do here, we're basically checking that if this value is in this collection, which it is, right? Because that was an array. So then allow is going to be true. So we will allow developer, but for now we have no more conditions. So what we want to do here, we want to add more conditions to this. We want to ensure that any developer can read or list users, but nothing more, at least not in this rule. So we're also going to have to check the request here. So if the input request method is equal to get, and in the input request path, and that was an array, so I'm just going to do this, it's equal to users. We can see now that, okay, so if the user is in the developer group and the request method is get, and the first path component is users, we should allow the request. So this request should be allowed. Doesn't matter, the name here doesn't matter anymore because obviously we wouldn't want to build policy that depended on that. We can see here that, I think I can enhance some more here. We can see that querying this now, yes, we are allowed as expected. If we change this to something like put, you can see we're no longer allowed. Or if we keep the get here, but we change this to, I don't know, report. And we query it here now, we're no longer allowed. So we're basically, what this simple rule said is that any developer should be able to list users. Sorry. So that was one simple rule. And what if we wanted to add more? It might be that a very common thing to want is that you have an admin role. And the admin should be able to do pretty much anything. So if you want to add more conditions to this rule, the way you do that is basically just add another rule with the same name. So allow is equal to true. And the way this is interpreted is if any of these rules are true, then the decision is going to be true, or the final outcome is going to be true. So you can have as many rules as you want with the same name. And if one of them is true, the response is going to be true, or the decision is going to be true. So in this case, we might just want to say admin and input user roles. And in this case, we don't check anything more. We don't check for the method. We don't check for the path, and so on. We just say, if you're an admin, anything goes. We don't care. You can delete the whole user database if you so wish. And as a third little rule, we might want to add something. We might want to have some endpoints that are actually fully public. So if the input request method, we still just want to allow read request, but if the input request path, or the first path component is equal to public, then we want to allow that as well. So in this case, we have three rules now. We have one that says an admin can do anything. A developer cannot do anything, but they can read all the users, or they can list all the users. And any user, regardless of role or name or so, can read from the public endpoint. And of course, we already tried most of these rules here, but if I change now to this user to an admin and I send a delete request to some unknown endpoint, doesn't matter here because it's not something we considered. The admin is allowed to do that. We're not gonna have any say on that. And if we change this to I don't know, noob, and we try and read public foo, see that even though I'm not in any known role, I should still be able to read on the public endpoint. So that's basically three types, or the same rule, but for three different conditions. So of course, in it, like when working with code, you can obviously do things like this. You just query OPA using the OPA eval tool. That's obviously like a very simple way of knowing what's going on. Once your kind of rules start to grow, you're going to want something more organized than trying things out like manually. So I talked about in the past like the OPA, the test framework that OPA ships with. So I think we have some time to demonstrate that. So rather than doing this manually, I'm going to create a little test file here, so we can grow confidence in our policy over time. Because of course, what we want to ensure is not just that, okay, this thing here works right now. We want to know, like, in 2 months from now, when a colleague does some changes, we still want to know that any user can still read from the public endpoint. The admin can still do this or that. So we basically want a test suite. So I'm going to create a new package here. I'm just going to say policy test. And I'm going to import the same path, like the same rule we worked with here, data policy allow. I'm going to just import that here instead, so we can work with that the same way we did with OPA eval. And the test is also just a regular rule. So the same kind of syntax, you just prefix that with test. So I'm going to say allow if admin. And the tests work the same way. They are also just a bunch of assertions. But since we don't have like a way to provide files in test, we're going to want to mock some data here. And there's a pretty nifty like way of doing that. We can just say allow with, and now we can mock anything. So we can say with input as user roles admin, and in this case we could this is that user roles admin. That looks neater, I think. Let's do that. So we can see now, regardless of what's going on here, as admin. Okay, so if we evaluate the allow rule with looking at this, it should be true. Let's see if that works. So I'm going to say OPA test. I'm just going to run it on the entire directory, and it says pass. Yeah, so indeed, that does work. The admin, if I provided the role admin here, it does work. And I could say, I could expand on this and say with input request method as delete. None of these things really matter because the admin should be able to do anything. But it could still be useful to add assertions that this works. And all of these, any test can contain any number of assertions, or you could just add more tests. So that was the first thing. We wanted to assert that the admin can do anything. The next thing was, of course, allow developer to list users. So I'm just going to say allow with input as, or input as user roles. And we need to be in the admin group here, or developer group. And the request method needs to be get, right? And the path should be users. Okay, let's try that out. Yeah, we now have 2 passing tests. And of course, since we're all good developers, we are going to want to add a negative pass as well. So we're going to say deny
non-developers, just users. So we're going to just try this same test here with some other group. I don't know, the janitors. They should not be able to list all users. And I'm going to say here, not allow. I'm going to try this. I'm going to see that that indeed passes as well. So lastly, I'm just going to say allow public access. First, like our last rule here, it's just a public endpoint. Public, let's say, read access. So allow with input as request method is equal to get, and the path to public. And we'll see. We now have 4 passing tests. So okay, this is basically Rego policy offering in a 5-minute demo. But this is basically how you start to kind of extract the rules out of your application, the things that you previously had hard coded, and you start to move that into Rego and start to move that into OPA. Basically, when you see this the first time, you're like, I remember I saw this the first time. I'm basically like, why would you do this? This is just a simple if-else statement. It doesn't need to be advanced. It's not the point of this. It's not that it needs to be like super complicated, but if you consider most things that you'd use a database for, it's not very complex either. You could just send it off to a file somewhere. The benefit of this is, of course, that if you have 13 applications and they're all written in 13 different languages using 13 different frameworks, I can assure you that there's going to be a bit of a difference in all of these implementations. And there's going to be a ton of differences in how those applications do logging and in how those applications enforce those decisions. So the idea here is that we try and unify this so we can work in these diverse environments while still having the confidence and knowing that our policy is enforced across this whole diverse heterogeneous stack. So that's basically OPA, and that's basically Rego. So this is a Kubernetes meetup or a CNCF meetup. There's probably a lot of you folks working on Kubernetes. So a very common use case for OPA is this. It's Kubernetes admission control. How many of you are familiar with that concept from before? Yeah, most of you. But for those who are not, the way it works is kind of like this. When you do something, when you do any command in Kubernetes, where you're trying to change the state of the system. So it does not apply if you say kubectl describe or kubectl get. Then this does not apply. But if you try and change something, you try and modify something, you're basically when you say kubectl apply, you're basically saying you're doing an update statement or an insert statement if this was a relational database. And for any of those commands, they need to pass a series of modules in order for that command to be accepted and eventually be persisted in etcd, which is the database backing Kubernetes. So first off, we need to authenticate the request. Next, we need to authorize the request. And next, we could, if we wanted to, we could mutate the request. But more importantly, we can validate the request. I'm going to get into more of what these steps entail later. But worth knowing is these modules are chainable. So you can have as many admission controllers, or as many authentication methods, or as many authorizers as you want. And of course, Kubernetes comes with a bunch of built-ins that you can use. And I guess most of you have worked with RBAC. It's pretty hard to avoid. But similarly, there are validating admission controllers and mutating admission controllers available for use directly. But what's really interesting for us, from an OPA perspective, or even if you don't choose to go with OPA, this is really where
where you have a chance as a developer or as a hacker to do something funny or interesting. That's the webhook option. Basically means rather than trying to use one of these pre-modeled and pre-made modules, you try to say, just send me a request. Just send a request with the data to my own webhook, where you get to do whatever you want with that. And then you can send back a response, and the Kubernetes API servers are going to act on that. And if you think, hey, that sounds familiar, we have a service here, and it sends a JSON request somewhere, and it gets back a JSON response, and it acts on that. Yeah, where does that come from? That sounds very familiar. That's the OPA, that's the policy decision model, right? So OPA was not built with Kubernetes in mind, and Kubernetes was not built with OPA in mind. It just works perfectly following this model. So while there's a whole bunch of modules here, I think the one we kind of tend to focus the most on is the validating one. And the reason why that is, by far the most popular module to extend, is basically because it allows us to build these kind of guardrails or moat around our clusters. It makes us feel like, okay, I don't feel like, even if you're an admin or if you have like elevated privileges, you don't need to feel like, oh, what if I do something wrong? I'm gonna like bring down the cluster. So this is not just to protect us from like stupid developers in some team somewhere, but it's just as much to protect us from ourselves, because we tend to do a lot of mistakes ourselves as well. So policy here essentially builds guardrails around your cluster, where you say things like any container or deployed here must be sourced from one of our own registries. You can't just go out to Docker Hub and fetch down like anything that you found on the net. It must be from our own corporate registries or our own, where we have some level of control. It could be organizational policies, where you say any resource deployed, whether it's a pod, a network policy, or an ingress, it needs to have a clear label defining who owns that resource. It might be a cost center, it might be a department or whatnot. But these are more like organizational things. It doesn't really mean anything to Kubernetes, but it could mean a whole lot to us. Other common rules that people tend to enforce, ingress, host path uniqueness. So if there's one ingress that has kind of claimed a particular path, you don't want another ingress that would then override that. You might want to enforce TLS for your services. Some attributes which you deem unsafe, like host path on your volume mounts, you might just want to say like, we don't allow that at all. No workloads here should be able to read files on the host. You might want to say that any given pod in this namespace could at max utilize 2 processors or 4 gigs of memory or whatever you want. Pod security policies are basically anything. Whatever is in the input data, if you have an idea where you say like sounds like a good default or a good thing to enforce, you can do that with OPA. It's just JSON in, JSON out. So basically from the demo, this should be fairly familiar by now. We have an input document, which is just JSON again. So whether it's authorization for like a microservice or it's the Kubernetes API server, as in this case, sending something, it's just JSON. So in this case, we just say, we got a pod here with 2 containers, and our simple policy here just check like, if not, input request, object metadata labels cost center. If there's not a cost center label, we'll just deny the request. In this case, we're a bit more friendly to the user, so we actually send back a string. And this will be, when you say kubectl apply, this is what you're gonna see. Oh,
Every resource must have a constant label. Good. Then you know exactly what you did wrong and how you can remediate that. You just fix it and you redeploy, and we're all good. And we can ensure that for all the resources in our cluster, we have a label clearly marking who owns that resource.
I have a question in between.
Yeah, sure.
Meaning all the input files that we can set in, for example, when using Helm and deploying Helm charts via CI/CD pipeline, GitLab, or Jenkins, whatever, I can scan the Helm chart for specific values, present, not present, and setting up rules on them, right?
Yeah. So you can either do that, you scan the actual Helm charts. But I think a more common way of doing it is like, since these policy checks run as part of like inside of the Kubernetes API servers, that's a much later stage than Helm.
Mm-hmm.
Like eventually, when you have like a Helm template and you have values, it eventually all just boils down to a regular Kubernetes resource. So yeah, unless you really need to, I think the common way of doing it is you just have an admission controller, which says, okay, any deployment must have at least 2 replicas. Mm-hmm. And then it doesn't matter. Did that deployment did that come from a Helm template, or did it come from just somebody sending in deploying via YAML file? Was it what else is there? So there's a lot of ways of doing this. You could even use things like what do you call the name escapes me now. But
there are gatekeeping to prevent developers deploying self-created charts.
Yeah.
Missing a lot of values and configuration parts.
Yeah.
It's like having a label of production, deploying the pod to production, and just no replicas.
Yeah.
Just as an example.
Yeah.
I can set a policy that production label contains production, to cluster, blah, blah, namespace must contain replica set of 2.
Yeah.
And such.
Yeah.
And if not, boom, you're fired.
Yeah. No, for sure.
Cool.
Yeah. All right, so that was Kubernetes mission control. Just a quick glance into, I think we're, a quick glance at another very common use case, and you'll see a lot more of components over here. And that's the one where we're dealing with authorization. And that's, I think, like Kubernetes admission control and authorization, that's probably the two, like, the most popular use cases for OPA. But there are tons more. But just to give you an idea what this might look like. So the old, and what we're showing on this map here is basically the zero trust security model. If you went back in time to the ancient past of like 5 years ago, and you ask someone like, where would you do authorization? They would say, you do it here. Or you do it before that. You do it in the gateway. That was the time of the API gateways. And if you went to security conferences 5 years ago, there were all these API gateway vendors there. And they would all talk about how you do authorization or identity checks and so on in the gateways. 5 years later, there's no API gateway vendors in any of these security conferences talking about that. So because they basically understood that if you only do authorization here, what if this service over here needs to talk to this service, or this service over here needs to talk to that service, which happens all the time. You might want to run a cron job inside of your cluster. So if you only run, like if you only verify identity and you only verify permissions at the perimeters of your system, like basically anything inside of your system is going to be unsecure, or they're just going to have an open highway to anything.
No, the answer to that problem was, yeah, you have to use the API gateway wizard.
Yeah, so that's basically what they have done now. They've kind of tried to they basically tried to move the API gateway into each of these containers, which is basically also what Envoy, Istio, and all these technologies are doing. Like building a mesh of these rather than to do it at one place. You have to do it everywhere. So the benefit of this model is, of course, that even if this service or that service wants to talk to the database directly, it cannot do so unless it has the right credentials and it has the right permissions. The challenge of this model is, of course, that there's a cost associated with all of these lookups. And if you have to go to a database somewhere and see, like, oh, I have a token here, who's the user, and what is he or she allowed to do? If you have to make an external request for all of this, you're in a pretty bad place. If you need to add like 5 milliseconds of latency or 10 milliseconds to each of these, and any of these requests requires like 10 or 20 of services, you kind of blow your latency budget just for doing secure or like just for authorization or authentication. So the way it works, again, you deploy OPA as close to your applications as possible, as many OPAs as you need. There's no centralized OPA. They all kind of service their own app. But of course, you still might want to manage OPA centrally. You might want to have one place where you like, here's my policy, here's my data, and you'd have this control plane and then distributing that out to your OPAs. But it's an asynchronous pattern. It's not asynchronous. So when a request comes in here, it doesn't have to go to the control plane. That's already been dealt with asynchronously. So there's not much more to say here. I just wanted to give you guys an idea what that kind of model looks like in a modern system.
I have a question regarding the distribution.
Yeah.
How do you ensure a consistent state if you have a sidecar in each pod and you need to deploy them individually?
Yeah, you basically don't. It's like with all these kind of cluster models, there is always the risk that one of these might have got their data 1 second ago, another one might have gotten it 5 seconds ago. So eventually they'll be consistent, but there's no guarantees. And if you want to or need to work with those kind of guarantees, there are obviously ways of working with that. Like kind of out of the box, the assumption is that, okay, if we make an update here to a policy, it's gonna be out there in like 10 seconds. But in the time during, we can't ensure that it's not gonna be, they're all gonna like update on a key switch. It's just gonna be a thing to deal with. But I think it's not a problem particularly for authorization, where it's basically with any distributed data.
I just have a second question to the pro. Is it a way of when I start to deploy, I'm able to deploy a service without sidecar? Is it a way to prevent other services talking to it, like detecting if sidecar policy is there?
Yeah, sure. So the way you normally deploy a sidecar is you deploy it bound to the localhost interface. So when you bind a service to the localhost interface and not the public interface, there's no, like, you can't physically communicate to a service which is only bound to the localhost interface from the outside. So yeah, does that answer your question? There's no way to reach that service.
Like to prevent someone deploying a malicious service inside the
Yeah, of course. Yeah, of course. You wouldn't want other services to reach your OPAs here.
Yeah.
All right, so that's basically it. If you find that interesting or you want to try it out, some suggestions from me here: you start small, learn the basics, try it out, pretty much like we did here in the demo. Just gonna try and write a rule, maybe a unit test, run it, try it out. There's also the Rego playground. Yeah.
Sorry. I still have a small question which actually would have belonged to the validation part. But what I'm interested in is a more complex scenario. I'm using OPA like for simple things like adding a flag like protected to a namespace so you cannot accidentally delete it. But I think you have more complex things inside CI/CD pipelines, like validating Kubernetes YAML files against TRDs. Is there like a library or something you can import? Is there something, or is it
Right,
a
so-
solution for it?
Right. So you want to validate the files before they even hit like the Kubernetes submission control. Yeah, there's a lot of people doing that. The most common like library or kind of side project doing that is called ConfTest, which is basically a side project within the OPA organization, where you rather work with files and you verify data rather than policy. So conftest.dev, check that out. It's basically OPA tailor-made for working with files and large volumes of files. Because OPA normally, again, it's a REST API, so you expect input over an API, and then you can respond with a decision. It wasn't made to work with files. So the contest is an adoption of OPA to do that. So check that out. All right, so if you want to get started, start small, browse the OPA docs. And again, I'm a big fan of actually doing something useful, not just toying around. So maybe again, and as I said, your applications are full of policy already. There's it's not like OPA invented policy. It's everywhere. It's just, do you deal with that in a decoupled, nice manner, or is it like hard coded into your applications? So consider some of the applications you work with. Maybe just try it out for a single endpoint, or maybe a single role or something like that. Rather than having your app make that decision, send it over to OPA and try it out. So delegate responsibilities, deploy, build experience, scale up, and once you know the basics, you can look into like the more management or like enterprise capabilities of OPA, meaning things like you can have all the OPAs deployed, log all the decisions they made. They can send that back to the remote control plane, and by remote control plane, it doesn't have to be like something commercial. It can be as an S3 bucket or something, whatever you want. And they can also additionally go and fetch your policies from a remote endpoint and a whole lot more. So there's like the hacking aspect of it, and there's also like the more big corp aspect. And of course, since I work for Styra, there's the Styra DAS, which is the Declarative Authorization Service, which is our commercial control plane. When you grow at scale, that could be something to look into. The Styra Academy, it's a free online resource for learning Rego and OPA. And there's also the OPA Slack, where we're almost 6,000 members now. So I think that's basically it. Is there any questions? Or there's been a few questions asked already.
Yeah, could you go back 2 slides?
Of course.
Great. Given this scenario, we'll have this cluster. There is a central control plane that is distributing the policies. Do I have to manage that myself, or is there like a help job out there or an operator that distributes all these?
Yeah, right. That's a good question. So basically, I mentioned in passing that it's a synchronous model. And ideally, you can configure OPA in a lot of ways. So you can either have like a service that pushes data into OPA, pushes updates like policies and so on. Then the drawback of that approach is like the same thing you asked, but then that service needs to have access to all the OPAs, right? So the ideal model I find is the bundle model, where you can configure all the OPAs and you just point them like, here's my control plane. And again, it doesn't have to be like something big. It can just say, here's my S3 bucket. So I want you to every seconds or every 10 minutes, depending on your requirements, you go and check, is there something new at that endpoint? And if there is, OPA is just going to fetch it and load it. And then 10 minutes later, it's going to go back and check. And it's just going to continue that cycle. So by using that kind of pool-based model, you don't need to expose your OPAs, and there's no like synchronous dependencies. But of course, if you have my permission data is like updated 10 times a second, yeah, that's might be a tough sell. Then you might need to look into other models. But I think for 98% of all OPA deployments, that's the best model.
Another second question.
Yeah.
You told us that the Kubernetes control plane can hand off the decision for authentication of authorization to OPA.
Right.
Do the cloud providers support this? So my AKS cluster or my GKE cluster.
Right. So
self-hosted OPA.
yeah. So in general, they support these two modules. They allow you to install a webhook here and there, but not here and there. So authorization is like, that's a very special case for OPA. I wrote a long blog about it at some point. It's doable, but you basically need to own your cluster. You need to run it on-prem if you want to use OPA for that, because there are so many assumptions as for Kubernetes authorization, and so many like hard-coded into Kubernetes itself, where they basically, yeah, it's really a bit of a cop-out, the authorization like web hook. So you can't, for example, say like, oh, go and get it at this endpoint, like at this URL, because Kubernetes then says, but at that point, like you're going to need authorization at kind of the bootstrap level. And at that point in time, we might not even have DNS. So you can't just say like, go to the endpoint at www.this, because they're not, you basically have to point it at like an IP address. So it's there's a lot of gotchas if you want to do this. I've done it, and it's a fun exercise, but it's not for everyone. So I think like in general, these are the two that you have like at your disposal if you're not running on-prem and you have a lot of time on your hands.
So Anders, thanks a lot. Say, you were talking a lot about OPA, and then there was Styra. What's Styra?
Right. So Styra is, again, it's the founders of the OPA project, and we're definitely like the main maintainer, even though it's an open source project, but we have a team dedicated working only on OPA. But yeah, basically we provide a control plane to manage the OPA at scale. And I think like OPA it's almost too good for needing us. But I think like so if you have like a couple of OPAs, a couple of services, you'll do just fine. They'll just use an S3 bucket or whatever you might want to need. But once you start to scale up, and you might have hundreds of OPAs or thousands of OPAs. I was like the company I was in previously, we had 700 microservices, and we need a way to know like what policy applies to these services labeled by this or that. And even worse, we need to know like what policy was in action or was applied 2 months before that. And at the exact same point in time, when an auditor comes and asks, like, why was this user allowed to see this account of another user that they should not have access to? We needed to answer that question reliably, and we needed a system that would allow us for that. So things like that is basically what Styra provides. There are a lot of nice like management capabilities, things like being able to replay decisions later. Again, remember how you can configure OPA so that any decision it took is logged, and like 2 months later, you can go back and you can say like, give me the policy as it was at that point in time and the input data I got at that point in time. And I want to replay that decision now to see why this decision was made. And you can kind of back on that. So again, the benefits
of decoupling policy from applications. Like, good luck trying to replay a decision made in like a Ruby on Rails app 2 months later, after like 200 deployments after. It's not doable. You basically need to have the entire store of the state of your database at that time, and the state of the application, things like that. And yeah, that's just one of many features. So, but basically, it's a commercial control plane, and there's a free edition, which is, I think it's very, very useful on its own. So if you want to try it out, just Google it, stare at us, or try it out, start an account. You can have I think you can do a lot with that before you hit any limits.
Great. Thanks a lot.
Thank you for being here, and thanks for the collaboration we have
today.
today. We have Poseidon and Styler coming to us, and it's hosted by TTTech,
So see you right down. It's a company TTTech, and as you can imagine, all of them are hiring. So if you're purchasing a job, you can of course talk to Anders, talk to me about different companies. So it's not that you will volunteer, the people on the stream would not like to volunteer. So we have things, of course, but nobody found that. They're in British. Nobody told us. I'm really sorry. We meant it a bit too good. We wanted to have cool drinks, and yeah, we didn't put them out. So drinks in the fridge, and we'd like to order pizza, burgers, and we won't do both. So there's a really good burger joint called XO Grill to the left, where one of us will go and fetch burgers. Or there's quite a good pizzeria called Randale. It's the daughter pizzeria of Pizzeria Volante. Some of you might know it, Disco Volante. And we now have to vote on, are we even hungry? I mean, that's the most important question. So who's hungry? Okay, that's hell. And now I will ask who prefers burgers, and then I'll ask who prefers pizza. And yes, the burger joint has a vegetarian option. So burgers, pizza. All right, pizza it is. So we go to Randale and we talk to each other which pizzas we'll order. Thanks a lot, and we'll continue in around about 10 minutes. So 40 minutes past 6, we'll continue with Damjan, talking about other possibilities to use OPA for. See you then.
community is a big or is really important for us. Yeah. Hello. It's really important for us. We said we want to join the CNCF community and also be part of it. And that's how we collaborate with Stura. And we also really focus on big enterprise customers in the cloud native space to develop their solutions at the end of the day. And a lot of the founders are here, like Damjan, who will present in a few minutes. Also Hannes is here and Tamas. So if you have any questions or if you need any support in regards to Stura, we can also support besides Anders. And yeah, thank you that you took the time today. And that was a short overview. If you want to know more, we have a lot of beer to drink today. So happy if you connect on LinkedIn. And yeah, hello everyone outside of this room. Thank you.
Hi everyone, thanks for joining. I will share the screen and we will get started. So yeah, Nicholas already talked a little bit about the company. I can say a few words about myself. My name is Damjan. I'm originally from Skopje, Macedonia, moved to Vienna almost 10 years ago, where I studied at the TU Wien software engineering. And after that started working first as a backend engineer, then full stack, then DevOps, cloud, and now I'm kind of a platform engineer and responsible for the technology department at Posedio. I will be talking a little bit about how you can use OPA in different places of your tech stack, so getting a bit creative with it, how it can help you evaluate policies at different places and what the benefits are of having the centrally managed policy place or a control plane that you can then use from different points in your tech stack. I will be trying something different today. So instead of like using normal PowerPoint or slides, I'll be using Excalibur, which is my new favorite drawing tool. And I will try to scroll around, open some links, show you some things. This is why I have the huge tab list here. And hopefully spark a bit of a discussion. Since we're already a bit late, I might move things along a bit faster, but please interrupt me if you have any questions, and then we can discuss the topics that you're most interested in. So that said, let's see how this works out. So what I have here as a very big overview is kind of what I would call, let's say, a standard mid to large enterprise that needs to develop software and needs to have some sort of compliance overview over that software, how it's developed, how it runs, how it serves users. I will start at the bottom here, where we have Sarah, a compliance engineer. And Sarah is here with a walking stick because she used to be very slow, because getting something approved by the compliance department is always a slow and tedious process. They have, however, recently kind of moved to OPA, where they have certain policies that they develop and enforce throughout the organization. And this has sped them up significantly. And this is what I would like to kind of point to today. So the first thing that we have here is, how do you even develop policies? And since Anders talked about this already, I won't get too deep into it. But what I would like to point out is a few best practices that you have here. So the first thing is, of course, you can reuse the development best practices that we're used to, and you can apply them to policies. You can have version control, like Git. You can have code review, where you have like the 4i principle, or even some sort of approval process or formal approval process. You can have change management, which of course allows you to track those changes and make sure that they're rolled out properly. And finally, one, I think, very underrated aspect that Andres already touched upon, policy testing. So you can really have this CI/CD pipeline even when you develop policies, to make sure that the policies meet the level of quality that your organization needs. Of course, developing policies is not the only job of a compliance engineer. They also have to maintain those policies. So it's not enough to just have them out there and have them developed once, but you also have to maintain them. You also have to make sure that they're enforced. You also need to know how the whole thing works. and are the decisions made in a way that is compliant with your organization. So here again, OPA offers a lot of helper tools. What I find really cool is there is this policy metadata option. So if you take a look at, instead of searching, I'll just go metadata. So there's this very cool feature where you can just tag your policies with some metadata. And this metadata, they have certain annotations which are already kind of preset, but it allows you to follow a certain, let's say, again, policy, or it allows you to have a structure in the policies themselves, in the code, that is even parsable, so you can inspect it. You can also have a Go API that actually reacts to this policy, so it can be extended and it can serve your needs. But most importantly, it serves as a documentation of sorts, so it allows you to document certain things like a description that explains what this policy does, which of course makes it easier for not just the people who write the policy that need to then maintain it, but it also makes it to point easier for people that rely and use these policies. Because then you have a description, and then if you have a company culture where code is open to everyone and anyone can see these policies, they can go through the code, they can read what the intent was and why the policies are there. The next topic is the decision logs. I mean, Andres already mentioned this. So one great thing and very useful for a compliance engineer is to actually be able to follow the reasoning behind the decisions and actually inspect and provide to an auditor a list of decisions that were made and the reasoning why they were made. So OPA exposes this in a very elegant way. There is actually a way that you can register a backend, so a logging system, and every time OPA makes a decision from any of these sidecars or from any agent that you have, it will actually stream the logs to this central system where you can store them, you can parse them, you can alert on them in case something is suspicious. So you can do actually a lot of things with them. And of course, you can keep them in for compliance reasons and for auditing purposes. Again, this is something that you can play around with, the decision logs. Like one thing that often gets overlooked when you deal with logs in general and OPA decision logs in particular is just the amount of logs that you get. So one problem that can pop up is just rate limiting. OPA has this again considered, it's built into the system, so you can do some rate limiting on the logs. And of course, you can decide how you want to store them and how important they are for you. And the final job of a compliance engineer is, of course, to publish these policies. So make them accessible, push them out to all the places where the policies are being evaluated. And this means for OPA, it's very easy to publish policies, or relatively easy to publish policies, because they offer this policy bundles approach that Andres mentioned. So you can actually bundle your policy and expose it as a package that can then be reused. And they offer this discovery mechanism. So you can advertise your control plane, and then every sidecar or every agent is then capable of accessing the control plane and fetching the policy bundles locally. They have a lot of cool features in addition to that. So there's caching there. There is mutual TLS or one-sided TLS, so that you can make sure that your agent or your sidecar talks to the correct, that the server is allowed to talk to the sidecar. There's a lot of effort there to make sure that, because this is again a critical point, if you are able to send an invalid or a fake policy or a malicious policy to the agent will of course then evaluate that and allow requests that are potentially dangerous into the system. And of course, we don't want that. So there is effort being put into making sure that these policy bundles are protected and can be delivered to the agents in a way that is secure and that is tamper-proof. So once our compliance engineer has created her policies and has this, yes?
How is it done? It sounded a bit vague. If it's done in a secure way.
In best case, using MTLS. So you have certificates in the control plane and you have certificates in the sidecar. Exactly. exactly. So the traffic is encrypted between them. When you set up the agent, the sidecar, you have to tell it, this is the server that you will talk to, this is the certificate of the server, and this is potentially the certificate authority, so the entire chain. And then this is your private key, and then issued probably by the same authority, so that they can actually create an HTTPS connection point to point, which is then checked from both sides. So standard, if you think from a browser perspective, only the server side certificate is verified. So when I make a request to any web page, my browser verifies the certificate of that server. But what we want to achieve is also, from the other hand, sometimes that the client itself also authenticates to the server. In this case, we have this mutual TLS. So this is the standard practice how you would set it up. You would do it with certificates on the network layer and encrypt the traffic. Of course, there are other ways. Of course, it's also possible to build your own custom way. So you can say, I will make sure that somehow the policy reaches the file system of the host. And then you can say my OPA agent trusts only the file system. That would be one approach. But of course, then you have to make sure that this policy is delivered in a safe way. So once the policy is there, we need to figure out what we actually use it for and how we can use it. And I will then take you to the top, where we have Bob, who is sort of a platform engineer. This is a bit of an overloaded term, but I will walk you through some use cases, and then, don't focus too much on the title, focus on what Bob needs to do. So the first thing Bob needs to do is create a cluster, probably in a hyperscaler, probably with Terraform. And this is where this tool conftest comes in. So this is a tool where you can actually, so it's an open source tool, also developed by OPA. So again, Stira contributes here significantly. But in general, I'll make it bigger. It is a tool that allows you to write OPA policies and then run them against files, in a sense. It also allows you to write tests, which means that you can get, in the end, like a nice summary, and you can get, if you think of introducing this to a CI/CD system, you can get a quality gate. So what this means is you can have, I have some examples here. You can have different, or you can use it to evaluate this different systems. So in our case, we set Terraform, so we can take a look at HCL, which is this HashiCorp configuration language. In essence, what you would do is you would run a Terraform plan, which gives you an output of what Terraform intends to change in your system. And then you can convert this plan to a JSON, and it looks something like, okay, that's perhaps not the best view, but it looks something like this, where you have a list of changes that Terraform plans to apply, and a list of resources that it will impact, right? And what you can do with conftest then is set up a policy that, let's take a look in the example. It's still small, yeah. And can I make it day mode? Yeah, it's a GitHub setting, but I should be able to actually do it easily. This is a new GitHub setting, so it's a bit light default. There we go. So now we refresh, and there we go. So we have here a list of examples, right? What we're interested in right now is this capabilities thing, which I shall, this Terraform thing, which I shall open here. And here we have, again, some example of like what we want to deny, for example. So we say we don't want to allow changes to IAM, which is the Google Identity and Access Management resources. And we simply say, you're not allowed to change that. So there is like an admin that can set up the permissions and the access management in Google, in G-Cloud in this case, but your Terraform script is not allowed to touch these resources. You can also have different policies, like some examples here is, for example, you can limit the blast radius. So you can say you're only allowed to change 5 resources at a time, arbitrary number, right? Or you're only allowed to change 1 zone at a time and not multi-region. You can also enforce some metadata, which we already discussed, like a label, like a cost center, something like that. You can also say this label needs to be present in the resource that Terraform creates, and if it's not there, then we fail the build. You can also use it to simply test your configuration. Like you expect that you want to have 5 VMs started, and you know that this will always be the case unless somebody changes something that will require a change to the test as well. So if you see that Terraform plans to destroy some resources, obviously you need to fail the build because you want to just create a non-invasive upgrade without destroying resources, which could lead to loss of data, for example. Once this cluster is created, our platform engineer wants to actually manage the cluster. So this is something that Andres already touched upon. There are tools out there that can help you manage a Kubernetes cluster. One is Gatekeeper, one is deprecation. What they do is very straightforward. So the idea is you have these validation webhooks. Every request needs to go through them. And there you can check for certain best practice rules or policies. Like one thing is the metadata that we already touched upon. One thing is this is what deprecation does. It can look for deprecated APIs and basically reject an API that is being deprecated. This is a very interesting tool because this is quite often the case that developers, I mean, we had a small, or another team at the client had a small outage because they were using Let's Encrypt, and they were using Cert Manager to create certificates in the cluster. And then Cert Manager had certain CRDs that were deprecated, that with the new release, which Google then upgraded the cluster without anyone clicking because it was end of life, they were no longer supported. So suddenly there were no certificates in the cluster and no network calls could be made. If they had this tool installed in the cluster, obviously they would be able to detect, because this tool can issue a warning, they would be able to detect that they're using deprecated resources and hopefully upgrade on time. Other things that you can do from a cluster management perspective is like have a list of allowed images. This can be, for example, a private registry, so you can say any image from a private registry. This can be a specific image. This can be maybe an image per namespace. This is one use case that we have is every team, so we have a multi-tenant cluster and every team is assigned a namespace, so it's not a hard multi-tenancy, but still we want to have them either pull from like a central company repository or their registry or their team registry, so that they cannot fetch images from other teams, for example, based on some security policies. So you can really say, if the image has this prefix, then you can allow it in the cluster, in this namespace, otherwise I want to reject it. We can also ensure that there are resource limits in place so that one team cannot go overboard with what they request from the cluster. Of course, Kubernetes has some native ways of dealing with this, but if you have these resource limits as policies, then you can actually have them run in the pipeline so you fail early, and then enforce them in the cluster so that they cannot be circumvented. You can also have very nice error messages that describe to the user what went wrong, maybe point them to a Confluence page that says, here's the reasoning behind this, so developers don't just get mad at you, but actually understand why you made certain decisions. You can also enforce certain RBAC rules there, and it can be used for security hardening. So this Gatekeeper tool that I mentioned, I have here. And this tool is actually pretty cool because it's again maintained by OPA. It's open source. It runs inside the cluster as a webhook, as an admission controller. And it has a list, an open source list of, or a library of certain best practices that you can just apply yourself. We apply most of these to our clusters. Some examples are, let's say, image digest, which basically says, and actually the structure is really nice. I will walk you through it. So there's a constraint that says, we want to have image digest for pods in this namespace. So what an image digest is, the constraint doesn't really tell you because it's a bit decoupled, but you have that hopefully here in the constraint template, which actually tells you an image digest is, here's our Rego code. If we have an object that is a container, this container needs to match a regex, which basically means the hash of the image and not the tag, because tags are mutable and the hash is immutable. So always you want to be able to tell what you're running in the cluster. So if you run an image with a tag, you can never be sure. Someone could override the tag, then apply the image, then you have two images with the same tag, but actually different code is deployed. If you have a hash, then you know always what code it is, what code runs there. And this is something that we enforce in our clusters. And the library is really nice because actually it offers you really a well thought out list of different things. So if you were writing this yourself, maybe you would think, okay, I'll do it for containers. But then there are init containers, then there are ephemeral containers. So all of these things are kind of handled for you. And then in every example here in the library, you actually have tests, and you can see how they do the tests and what is allowed and what is disallowed. So this is an example of a disallowed pod because it simply has the tag here, and an allowed would be something with the hash here instead of the tag. And the test itself, so you can see it here, it's basically a gatekeeper test that says if the example allowed, then we expect no violations, and then in the disallowed, we expect certain violations. So it actually works pretty well. Right, and the final job, or the final for now job that a platform engineer would have is to manage infrastructure. And again, here, OPA can help, and it can help with some built-in or plugin mechanisms where you can actually control a lot of the things on the machine itself. So you can control access using SSH. This is one of the examples we have here. You can control, so this is the official documentation. You can control SSH access, you can control sudo access. You can also plug it into IP tables so that you can filter network traffic, and now the cool new thing, which is eBPF. You can actually plug it in an eBPF function on a kernel level so that it can handle security there, and it can also handle networking there as well. And we see now that a lot of companies are moving or exploring the eBPF space, especially for service meshes and routing, but also for certain security capabilities. And it's always nice if you can enforce policy there as well. So we have these requirements here for a platform engineer, but a platform engineer also needs to be able to run software on their cluster. And how we get there, we'll move back to our two developers. So we have John and Alice, a backend and a front-end software engineer, who have a very similar path up until they deploy the software, and then they differ a bit. So initially, they want to develop their software, they want to run it locally, they want to develop it locally, all good. So OPA offers actually integration with most IDEs. You can test your stuff there. We saw the CLI tool, so you can actually run tests locally as well to make sure that you fail as early as possible. So this shift left approach so that you can react as soon as possible and mistakes cost less. But eventually you want to have this software that you developed somewhere in version control. And here you can actually have pre-commit hooks. So there is this tool here called, this is another tool that I really like. Yes, pre-commit. In essence, it's a Git hook that you can plug into OPA, and you can enforce policies even at the commit level. So you can really have certain rules there, even conf test rules, that whenever a developer wants to commit something, this will run. And with this thing, they will either get the commit approved, so the commit will move through, or it will fail because a policy is violated. And this is very useful because you can enforce policies that are important to the organization, such as, I don't know, a style of a commit message perhaps, or perhaps who can commit to which repository and so on. So it's really a flexible tool. What you can also do locally is you can test your configuration. So this is again something that ConfTest can do for you. There is, for example, if you work with Spring or Java, you can actually test your Spring properties file. So it can take a look at the file and it can say, if you don't have a URL in your Spring properties where you expose your application, then the configuration is not valid, so I will reject it. Of course, this can be extended to any property that you have. For example, you need a database password, you forgot to put it. Obviously, you shouldn't put your database passwords in Git, but it can actually catch that and say, the application is not configured properly, it won't start in production, so I won't let you deploy to production to stop you from perhaps stopping an already running application to replace it with the new one, if that's how you deploy your code. Once the development is done and you've pushed to Git, it's time to build your software. Here again, Open can help you. So what you can have is you can have certain policies that plug into Maven or Gradle if you're building Java projects. So I come from a Java background, so I use some examples with Java. One example is, again, if we go back to ConfTest, what you can do is actually have this XML file, and then there's this POM XML, which is the Maven descriptor. And there you can have rules that, for example, check some versions. So if you have the Maven Surefire plugin, which has a version that does not equal this expected version, then it will simply reject your build and it will say you cannot build this because you're using, for example, a vulnerable version of the plugin. So whatever you build cannot be trusted because the tool you use to build it is actually not trusted. You can have arbitrary examples here. There's also a tool that can help you plug it into Gradle as an alternative to Maven. But what I find perhaps most interesting is that you can also use it for CI/CD. So if you think, again, what we use right now is GitLab CI, but it should be able to work with most CI/CD providers. If you think GitLab CI, what it does is it lets you define your build jobs in a YAML file. And YAML files can be translated to JSON, and OPA can evaluate JSON. So what you can do is you can even enforce policies on your build scripts. So you can say, for example, as a company, I want to ensure that every build has to go through a test stage. So maybe I cannot really look deeply into it and figure out if they test properly, but I can at least ensure that they have a test stage and they have a stage where the code goes through static code analysis, and I have a stage where the code does or goes through some other steps which ensure that I have this supply chain security in place and gives me a level of confidence that the build worked the way it was supposed to. It followed policy, it followed procedure, and what I have in the end is an artifact that's somewhat safe to deploy. Of course, you can never be 100% safe, but at least something that matches the process and the risk profile your company has. And then here it gets interesting. So on one hand, we want to deploy the software, and on the other hand, of course, we want to run the software. When you think of deploying the software, this is kind of a dependency to the platform engineering team because they provide the platform on which the software is deployed. And here we have this collaboration between the software engineers and the platform engineers. So the idea usually with these platform teams is that you have a self-service platform where you as a developer can decide what you want to deploy, how you want to deploy, and where. But of course, there are some constraints or policies that you have to respect. So what you can do is actually you can enforce policies on Kubernetes level. Like you can say this team, so from this pipeline, you're only allowed to deploy to this namespace. You can also say I require metadata. So you must have labels that say what team you are, that say what cost center you have, that say perhaps, I don't know, anything you can think of really. So any label that you can think of that your organization needs, you can enforce in Kubernetes, again, with the gatekeeper open source tool. You can also have these routing rules that Andres already mentioned. So you can say, I want the ingress path to be unique so that I don't allow people to steal traffic from me, basically. So otherwise, I could deploy an ingress that uses the path to your application, and potentially I can get traffic coming to me, where I just read the traffic, forward it to you, and then I have all your secrets. You can also do this on an Istio level. We actually do this in Istio. So one example is we have, as I said, this multi-tenant system where teams are allowed to deploy their code, and they're allowed to deploy multiple pods actually, and they can decide what the routing should be for themselves. The one requirement we have is that the paths must be prefixed with their team name, and that way we ensure that they cannot steal traffic from each other, because they cannot deploy anything that is not prefixed with their team name. So we have this OPA policy that says if your virtual service has, so in Istio, they have these virtual services which contain the path of the request, and if this path is prefixed by a label that we have in the namespace, which is the team name, then we allow it in the cluster. Otherwise, we reject it and we say you're trying to deploy something that doesn't belong here. Finally, there was, I think, one question in the last talk. So can you enforce anything on custom resources? We actually do this as well. So if you think back to this multi-tenant system, what we want to achieve is some sort of identity for the services themselves. So when you deploy an application, we want to ensure a couple of things. In the end, we want to know what application it is, and we want the application to be able to have an identity that it can present to other applications and other users. So first, what we do is we rely on the Kubernetes service account mechanism. So we say every application needs to run with a unique service account, and that service account needs to match, for example, the deployment name, because then otherwise I would be able to, even if like I'm from the same team or whatever, I would be able to create a deployment that uses a different service account, and then I can basically impersonate another service. So we don't really care what the service account is called. We just want to make sure that it's unique, and there is unique mapping between a service account and a deployment. Not a pod, but a deployment, because we can have multiple pods with the same identity because they are the same service. On top of that, we have this thing called Google CNRM. So we run in Google Cloud. This is basically a Google Kubernetes operator that allows you to provision Google resources using Kubernetes custom resources, so YAML files in essence. And we want to ensure, for example, that when you provision these resources, they follow a naming convention that matches the service account name or the application name or so on. And again, we have rules here because in effect, these custom resources are again simply JSON files. And we have a rule here that says in this JSON file, of course, we have the schema of the custom resource or the custom resource definition. We say in this JSON file, this entry here, which is the name or the label or perhaps some path, doesn't matter, has to match the label or the name of the deployment and so on. And in this way, we give the developers the freedom to actually deploy their own manifests to Kubernetes, while at the same time respecting these boundaries of a multi-tenant system, and we can enforce this policy throughout the system as well. So once we have this deployed, once it runs, we actually want to, on one hand, have the front end access the backend. On the other hand, the backend needs to have some sort of authentication authorization model, so not everyone can access the backend. And finally, the backend needs to access data. And I will start with the data access because I find it very interesting. So one thing you can do there is you can really filter data. So for example, I think Andres already mentioned it, you can have data that you query from a database. You can send that data to OPA, and OPA can give you a filtered list, which basically contains only the data your user is allowed to see. There is a very cool and I think somewhat recent blog post about this, which you can take a look at, and where it's really explained in a very nice way how you can achieve this and how you can have rules that can even go to the attributes of the data itself, look at the attributes and enforce certain policies. So basically they filter the data and then they only give you either the data you need, or they can even compile this to sort of a statement, a SQL statement that would allow you to query the data and get something which is kind of custom to this user. So only get the data sets the user is allowed to see. And I think this is a very powerful mechanism. And this is actually something that we haven't done yet, but we're looking into one right now with one of our clients. And hopefully, yeah, next time we can maybe do a deep dive on that, because I think it's a very interesting approach to define in a central place what data should be visible based on some attributes, and then have it enforced throughout all the applications so that the applications don't need to worry about who can access what. And most importantly, you can prove in a sort of objective way that even your application cannot alone go to a database and get everything. Even your application needs to have impersonate a user, in essence, through a JWT token or something else, impersonate a user, send this request to the database, have OPA intercepted, filtrate the data, and it will only get the data that it is allowed to have instead of have everything. So there is no more this privilege escalation where I come as an unprivileged user to an application. The application takes my request, uses its own admin credentials, goes to the database, gets everything, and if there is a bug, then I can see everything. So basically, the application gives me elevated privileges just because it needs to serve different users. In this case, you can really formally prove that there's no way to access the data because you're the one, you're not, or your application is not the one responsible for this access and for this policy enforcement. So a bug in your application cannot affect or should not affect data access. You can do the same with Kafka. So you can have, one example is on the web page where they have two approaches. So on one hand, you can have the consumer side. So is the consumer allowed to access a certain topic? And if this topic contains personally identifiable information, then you want to reject access. If it doesn't, then you would allow access. The second approach is from a producer side. So is this a high fan out topic? Are there a lot of consumers listening to it? If yes, then perhaps you need to be on a certain allow list instead of being able to just in a self-service way sign up and start producing data, because a lot of systems or perhaps critical systems depend on this data. And unless you went through some process of approval, you might pollute this data in a way that might end up, I don't know, breaking the system or having an impact on the business itself. So you have an explanation here how to plug it in. In essence, what I hope to achieve today is less kind of how you do it hands-on, but more of a big picture idea of where can I plug in my OPA systems and how can I get the most of it. And if I have a problem, can I think of, that's one solution that I can just use out of the box. So once we have the data access kind of sorted, the next step is authentication and authorization. So in essence, OPA doesn't really deal with authentication. Authentication is simply proving your identity to the system. Authorization, on the other hand, is exactly what OPA does. Authorization is, am I allowed to access a certain resource? So it has to deal with permissions and policies. What OPA offers is actually very nice integration with a couple of tools that can help you with authorization and authentication. One example is Istio or Envoy. Envoy is basically a sidecar proxy to a system, to an application that intercepts traffic and can enforce certain policies and routing decisions. Istio is a system built on top of Envoy that kind of provides a control plane for Envoy. So how do I push out these policies at scale, and how do I do these decisions in a central system, but then be able to replicate them to thousands of microservices. So Istio is a service mesh, Envoy is the proxy that is used by that service mesh to actually do the data plane, like service-to-service communication. And in both of these systems, you can plug in OPA to decide on whether a request is allowed or not allowed to proceed. And you can actually do very smart things. You can have, on one hand, this JWT authorization, so you can have a token, a JSON web token, coming with the request. You can decode it. You can verify that the token is signed properly. You can even make a request to the issuer, to this well-known OpenID configuration, to actually get the signing keys, verify that they're signed properly with those signing keys, get the roles like we saw, and based on the roles, make a decision to accept or deny a request. Istio also allows or has this built-in MTLS mechanism, so it has this certificate encrypted communication between two services in the mesh. You can also use OPA here, so you can say if the request is coming from a particular service for which Istio guarantees the identity, I will allow this request, I will deny it from any other service. You can do it very finely grained, so you can say, instead of just allow or deny, you can have, like we saw in the demo, you can have different rules for different endpoints, for different paths, and for different HTTP verbs. So you might be able to read something but not modify it, or you might be able to write something as well as read it, for example. So this is something that actually plugs in very well, and there are, again, examples on the web page where you can really take a look at first how it works with Envoy, but also how it works with Istio, which is kind of this tool built on top of Envoy. And if we take a look at what they have here, yeah, it's again this kind of policy Rego file, which tells you you're basically always allowed to get the health check because we want to know if the application is up or not. You're allowed if the user has certain roles and these roles are required, and then you can see here, like, these are the roles for the users and these are the permissions that you require. So an admin has these permissions and so on. And this simply plugs into Istio, and it kind of works out of the box. So your application doesn't need to concern itself with who is allowed to do what. You simply have your endpoints. You make sure that the only way to get to these endpoints is through Istio. This is this localhost magic we talked about. And then you can basically say anything that comes in, I assume is fine. And I have my OPA in place that will verify that policies are in place and that policies are enforced by Istio as they should be. Yes?
We have a tradition with this meetup. When the pizza arrives, we need to take it off because cold pizza is the best.
Well, second worst after getting locked.
So what do you think?
I actually have, how much time do we have? I actually have one more slide, so I'll be done in 5 minutes and then it's over. Perfect. So yeah, so just very briefly, it plugs into Spring Boot as well. Importantly, we have this separation of duties concept, which I find very interesting, which is very easy to overlook when you design systems, secure systems and policies. So I put it here as an extra. In essence, what it says is if I have a user that has two roles that are required for an operation, I don't want to allow this user to act as the two principals at the same time, or this principal to act as the two roles at the same time, because I don't want the user to both create a payment and approve this payment at the same time. So what you could do as a policy is really say, if a user has this role, they're allowed to create payments. If they have this role, they're allowed to approve payments. If they have both roles, they're not allowed to use them at the same time. And the final topic that I wanted to mention is this access backend thing. So the front end, of course, needs to access the backend, and it needs to go through this authentication and authorization mechanism to get any data. And one of the beauties of having OPA as a centrally managed policy is they can share the same policy, which means at any time the front end knows exactly what they're allowed to do, but because they can evaluate the policy locally before they make the request to the backend. And what this allows us to do is, and this is a cool new tool that I found out recently, it allows us to have feature flags in essence. So I will refresh so it's white. Means is you can have your front end evaluate the permissions locally, say if it's allowed to access certain data or not, and then potentially hide or show this entire data or a button or a page or whatever. So if it's not allowed to do something, then you get this flag off, so you can hide an entire table of users. If it's allowed, of course, you don't get the data, you don't just hide it in the front end, but like from a UI perspective, it's completely not there, so your application looks better. If you're allowed to do this, then you can actually show the admin button, and then of course this changes to flag on, and then you can see whatever features you have. And this is very useful, not just from an authorization perspective, but also if you think in terms of you want to do silent launches or you want to hide some features from certain users, you can have policies that enforce this and that hide or show data based on what you provide from a centrally managed place. So I think that's it for today, and I think it's a perfect 45 minutes. We'll have pizza and then we'll do questions if that's okay with everyone. So thank you.
Thank you very much, Damjan. Thank you very much, Anders. Thank you very much, Niklas. And thanks a lot to all the companies that helped out today, Stura, Presidio, and TT Tech. I wish you a pleasant evening. I hope you have pizza too at home. And we have Randale pizza now, so all the best. See you next time. Bye-bye.